All right. In today's video, we're going to look at solving radical equations and inequalities. We have a little bit of vocabulary to begin with here. And extraneous root is something that happens when we solve problems like this. And what it means is we may come up with an answer through the processes we use to solve the problem that doesn't actually work in the original problem. So we need to be very careful to go back and check our problems on these, or our solutions that we get. I've split this into several types of problems. The first type of problem here, I am calling the version that has just one occurrence of the variable in there. And so since the variable only shows up in there once, we should be able to do this with an arrow diagram. So we'll make that arrow diagram for that real quickly. 5 is not the next thing that happens. The next thing that happened there would be the cube root. I'll write that as a 1/3 power because those are the same thing. And after all of that, I'm supposed to end up with a 10 at the end. So if I work my way back to the x, I would say divide by 5 and then cube and add 4 and divide by 3. If I follow that along here, 10 divided by 5 gives me a 2. The 2 cubed is 8. 8 plus 4 as I move this direction is a 12. 12 divided by 3 is 4. And the question is, does x equals 4 actually work? And if I started with a 4 here and traced it back, 4 times 3 is 12. 12 minus 4 is 8. The cube root of 8 is 2. 2 times 5 is 10. So that answer checks out. The first one is x equals 4. Second type of problem, moving fairly quickly here because there's a lot to get done, involves radical expressions on both sides. And so what we're going to have to do, we also notice that this is an inequality, so we're going to have to deal with that as well. And we're going to take advantage of our knowledge of inverse operations. And if we square both sides here, then my 1/2 power to the second power becomes just to a first power. So 8x plus 6 to the first power is just 8x plus 6. It says that is less than, if I square these, the 3 gets squared and becomes a 9, and the square root of x squared is an x. And so if I subtract 8x from both sides, I get 6 is less than x. So I know that I've got a point at 6. I probably want to do a little bit of checking here, and I know because I have these square roots in the problems, there's limits to where my answers could be. So I'm going to take my first expression here and figure out what the domain of that was, see what kind of numbers I'm even allowed to use. If I make arrow diagram for that, times 8 and plus 6 and 1/2 power, my parent function is that 1/2 power that had a domain of x greater than or equal to 0. And then I come back here with a minus 6, that becomes an x greater than or equal to negative 6. And when I divide by 8, that's x greater than or equal to negative 3/4. 6 certainly is bigger than negative 3/4. And I can see in my second one here, that's just a square root of x, so that would say the x has to be bigger than 0, and 6 is bigger than 0, so I'm okay domain-wise here. But I do want to do a final check and see if these should be shaded to the right as my inequality indicated. So I'm going to test with a point here, and I'll use 9 for the x. And on the left-hand side, I've already got my arrow diagram up here. So if I plug the 9 in for x, 9 times 8 is 72. 72 and 6 is 78. And so I'm getting a square root of 78 on the left-hand side in the original problem. And on the right-hand side, I've got a 3 times the square root of 9. That's 3 times 3. So that's 9. And I know this is going to be 8 point something because it's not as big as 81. So yes, that checks out. Square root of 78 is less than 9. This 9 is a good answer, so I should shade this direction on here, and I can communicate that answer as 6 to infinity as my solution set. Okay. My third problem here, I've got a radical on one side, and the other side doesn't have a radical, but there's more than one x. So I need to take a similar start to this problem by getting rid of this square root, but that means I'm going to have to square on both sides. So square root of x plus 18 squared, those are inverse operations, so that just leaves me with an x plus 18. And x minus 2 squared, if you don't remember that, we did that with the area models there, x squared minus 2x minus 2x plus 4. So that is x squared minus 4x plus 4. This is quadratic. I need to make it say equals 0. So I'll put the 0 on the left-hand side. Got an x squared. That'd give me a minus 5x minus 14. Hopefully that will factor. We can check that with the area model as well. Got an x squared and a minus 14. And so this would say, got to multiply to negative 14, but add to negative 5. That sounds like a negative 7 and a positive 2. So negative 7x there, 2x there, x plus 2 minus 7. So 0 is equal to x minus 7 times x plus 2. Let's see if I can get this out of the way here a little bit. Scroll up some. Zero product property would say that that means either x minus 7 is equal to 0 or x plus 2 is equal to 0. This would say x is 7 or x is negative 2. And so now we should go back and check both of those answers. Okay. And if we check them, we put a 7 into the first one, we get a square root of 25 equals 7 minus 2. 5 equals 5, that checks out, so x equals 7 is a good answer. When we put a minus 2 in, we get a square root of 16 is equal to negative 2 minus 2, which says 4 is equal to negative 4, and those are not equal to each other, so x equals negative 2 is an extraneous root, and the only answer to this problem is x equals 7. As one quick little bonus problem here, we're going to take a look at what if you have a formula that has a square root in it and you're asked to solve for one of the variables. So in this case, we want to solve for the e, so we're going to do this with an arrow diagram. We're going to treat the e as if it were the only variable in this. That involves multiplying by 2, then dividing by m, putting that all into a square root, and that's it. Okay, I don't need that extra area there. That's supposed to get me to a v. So my arrow's coming back. I would need to square. I'm going to multiply by m and divide by 2. So if I take my v, the first step says to square it, multiply that by m, and then divide the whole thing by 2, and I have arrived at e. So there is my formula solved for e. All right, that we are going to call it good because that was a pretty long one, but lots of good information.